Hi students, in this video we are going to learn how to determine specific heat of a substance. To do this experiment, we require calorimeter, thermometer, steam heater, stirrer, water and lead shots. Our aim is to find specific heat of substance, that is here lead shots. So to do these experiments, the materials required, I am writing here materials required: calorimeter, thermometer, stirrer, steam heater, and water. So here procedure. First we have to measure the mass of the calorimeter with the stirrer. So I am writing here mass of the calorimeter with the stirrer. With the stirrer. Say this is M1. After that, we have to fill the calorimeter with 1/3 of volume of calorimeter. So say this is calorimeter. Inside we have a stirrer. Now we have to take 1/3 of volume of calorimeter with water. So fill the calorimeter with 1/3 of volume of calorimeter with water. Now we have to measure the mass. Here mass of the calorimeter plus water. Say this is M2. From this mass of the water, only water mass, right? Mass of the water. Mass of the water is how we calculate. See here. Calorimeter stirrer. Its mass is M1. Calorimeter stirrer plus water, that is M2. We want only water mass. So for that, we have to subtract this M1 from M2. That is M2 minus M1. Calorimeter stirrer water has more mass. So that's why we have to subtract this calorimeter and stirrer from M2. M2 minus M1. Now we have to take the reading of temperature of water inside the kilometer. Say this is T1. Temperature of water present in the calorimeter is T1. Take a few lead shots and place them into a steam heater. Now heat them up to a temperature of 100 degrees centigrade. Let the temperature of the lead shots be T2. I am writing here. Take a few lead shots and place them in a steam heater. Now we have to heat them up to a temperature of 100 degree. a temperature of 100 degrees centigrade. Now we have to measure the temperature of the lead shards. So temperature of lead shards, say T2. So now immediately we have to take these lead shards and transfer the lead shards into calorimeter. Now quickly transfer the lead shards into the calorimeter. Into the calorimeter. After heating up these lead shards, we have to transfer these lead shards quickly into the calorimeter. Now these lead shards settle down. Whenever we place these lead shards, they settle down, they go down. Now we have to take temperature of this mixture. Mixture means here lead shards, water and stirrer. These are present here. So we have to take temperature of this water mixture, right? So temperature of this mixture. Temperature of the mixture. Mixture means here calorimeter, water and stirrer, lead shards. That is T3. Now mass of the lead shards. Mass of the lead shards. Mass of the lead shards. That is, see here, to understand this, calorimeter with stirrer, that is M1. When we pour water, means calorimeter, stirrer, water, that is M2. Now calorimeter, water, lead shards, that is M3. So to get only mass of the lead shards, we have to subtract this M2 from M3. That means M3 minus M2. When we place these lead shards into the calorimeter, lead shards lost some heat. This is transferred to calorimeter and the water present in the calorimeter. That means net heat lost by the lead shards is transferred to the calorimeter and the water present in the calorimeter. The water present in the calorimeter. We know net heat lost by the lead shards is equal to net heat gained by the calorimeter plus net heat gained by the water. This is net heat lost by the lead shards will be equal to net heat gained by the calorimeter and net heat gained by the water. This is called principle of method of mixtures. Now let the specific heat of the calorimeter, say SC, C stands for your calorimeter, In the same way, the specific heat of water, that is SW, specific heat of lead shards, that is SL. Heat lost by lead shards, that is equal to heat gain by calorimeter plus heat gain by watt. Now we have to recall heat Q is equal to ms delta T. Net heat lost by the lead shard is equal to heat gain by calorimeter plus heat gain by the water. Heat gain by the water. Now we have to recall Q is equal to ms delta T. Using this formula, we have to write this equation. Mass of the calorimeter is M1. Calorimeter plus water. When we poured water, its mass is M2. When to this calorimeter and water, we added lead shards, then its mass is M3. Now we require only mass of the lead shards. So from this M3, we have to subtract this M2 to get only mass of the lead shards. So I am writing here, mass of the lead shards is M3 minus M2. And yes, S is here, specific heat of the lead shards, that is written as SL. Then temperature. See, to recall temperature, calorimeter, initial temperature is T1. Next, water, here water. Temperature of water in calorimeter. Temperature of water in calorimeter, that is T1. Temperature of lead shards. Temperature of lead shards, that is T2. When we place these lead shards, after heating this lead shard to 100 degrees centigrade, we place them in calorimeter. Now the temperature of the mixture means here water, stirrer and lead shards. So now temperature becomes T3. So recall this point. Temperature of water present in the calorimeter is T1. Temperature of lead shards, that is T2. After placing this hot lead shards in the calorimeter, its temperature becomes T3. Now here temperature of the lead shards, temperature of the, here heat loss, here net heat loss. So to find heat loss of the lead shards, see, temperature of the lead shard is T2. When we place these lead shards in the calorimeter, it loses some heat. So T2 is greater than T3. That's why we have to write here T2 minus T3. Because we heated the lead shards up to 100 degrees centigrade. Okay. After heating this, we are placing these lead shards in the water. Then it loses some heat energy. So that's why T3 is less than T2. So subtract T2 minus T3, that is equal to heat gain by the calorimeter. So heat absorbed by the gain or lost by the body, we can, using this Q is equal to ms delta T only, we get that answer. So here mass of the calorimeter, that is M1. Specific heat of the calorimeter, that is SC. And temperature change, that is delta T. So calorimeter change. Final temperature is T3. Initial temperature is T1. So difference is temperature change in the calorimeter is T3 minus T1. I am writing here T3 minus T1 plus heat gained by the water. So mass of the water. See here, mass of the water. Calorimeter plus water, M2. We need only water mass, right? So we have to subtract this M2 plus M3. Mass of the calorimeter is M1. Mass of the calorimeter plus water M2. From these two, we can find only mass of the water. That is M2 minus M1. So here I am writing M2 minus M1. This gives us mass of the water. Then specific heat of the water is SW. Now temperature of the water. Temperature of the water. See here. Initial temperature of water present in the calorimeter T1. Final temperature of the water is T3. So here we have to subtract this T1 from T3. T3 minus T1. T3 minus T1. See, initially its temperature is T1. After placing the lead shards into the water, its temperature rises to T3. So it gains T3 minus T1 heat energy. Temperature changes T3 minus T1. Now we have to find out, see, M3 minus M2 into SL into T2 minus T3, that is equal to, here if we carefully observe, T3 minus 1, T3 minus T1, here also T3 minus T1. So I am taking as common. See here, M1 SC T3 minus T1, M2 minus M1 into SW T3 minus T1. Here we have T3 minus T1, here also we have T3 minus T1. So I am taking as T3 minus T1, I am taking as common T3 minus T1. So put bracket here. Here write T3 minus T1. This is common factor. Now we are taking, generally we write here T3 minus T1. So here I am writing right side of the bracket T3 minus T1. Now T3 minus T1 cancels. So write only what is left. If we close this T3 minus T1, what is left? M1SC. Right, M1SC. After that plus symbol. Now close this T3 minus T1. What we left? M2 minus M1. M2 minus M1 into SW. Now from this, we want only formula for specific heat of lead shards. That is given by, write this right side of the is equal to. So this part I am writing here M1 SC plus M2 minus M1 into SW into T3 minus T1. Now send this M3 minus M2 and T2 minus T3 to right side of the equation. It will divide. So M3 minus M2 into T2 minus T3. Using this formula, we can find specific heat of a substance, right? In this case, substance is lead shards. So specific heat of lead shards can be found using this formula.